Okay, so for part 4, what we will add now is a function to delete a record. Okay, so let's go back to our application. Like in this example, we have 3 records stored in a list. And let's again see what they look like so we can run this. And as you can see, we have Frank sauce, okay? Even though it was the last item to be entered in the list, but it appears to be the first one. And that is because we're using a push front function. A push back function for that purpose. The rest used push front, which means we've tacked them or concatenated them to the end of the list, or in other words, the tail of the list. Okay, so that was pretty much where we left off last time. Now I'd like to delete a record. I'd like to have the ability to delete a record. Okay, so if we go back to the client list.h, we can see that I have a prototype already in place, but I don't have the function definition for delete record yet. And code-wise, it's not going to look any different or dramatically different from what we've done with a string. With an integer payload that had an integer primary key or unique key that identified that record. Okay, so on that, we're going to go over here, and under mutators, we're going to add another function. And this time, again, let's look at our delete record, by the way. Let's see. We have a delete record. You know what? We could change it to where it returns a Boolean. Why? Because we could use it to make sure that if the record didn't exist, we would return a false. So instead of just deleting blindly and not knowing if we actually deleted anything, maybe strategically I should put a bool here, right? And go that way. So forgive me again, I thought it would be a good idea, so let's go ahead and do it and see if we can implement it in the application. So I'm going to say bool client list, and that would be delete record. And let's see if we have it here. Delete record. Right now it's showing as, because I didn't save it. So let me just delete it again. Let's see if it sees the bool. It hasn't updated, but it doesn't matter. It will work. Delete record should be a bool. Let me make sure that that's what I have. Okay. So let's get back here. The parameters, in our case, client list, asterisk and %head. So go ahead and send the pointer to the beginning of the list. This time, string rec key. And the reason is I want in the application to tell it which record, based on which client ID, I want to delete. Okay. We have 2 situations in a case like this. Either the list is empty. In that case, we need to return a false. If it's not, then we need to evaluate within that list any record that has a key equal to the client ID. Once we find it, then we can delete. Oops, that will be list out lowercase here. Okay, so first, since we're going to traverse a list, so we need a pointer position, and we're going to initialize it to head. So just like any of the other functions where we need to do something like that, this has worked as a technique for us. So position and make it equal to head. Okay, so we will use this to traverse. Since we are deleting, we also need another pointer that will be lagging this one. So as we move forward through a list, one pointer will point forward, the other one points to the item behind it. That way we can do some sort of an ablation or removal with these two pointers properly. Okay? All right, so client list for now, have them point to the same position. And I'm going to call this one previous position. So if you've been following our series of how to create linked lists, and we've done it with integers, this is the exact algorithm that I'm using here. Okay. Next, I need a flag to return. So you basically either deleted something or didn't. So something like this, bool flag, and just at the end of the program, just return that flag. For now, if nothing happened, make the flag equal false. Right? So that would be the default value that you would want, like nothing happened. So if you ran this function by itself, right, it will always return false at this stage because we didn't do anything. So when will we'll have a scenario similar to that? What if the list is empty? Fine. So you could do something like this. If head equals null, right? Return flag. You could do that. Or I could have said flag equal false right here. But this just kicks me out and I'm done. Okay? Else, which means now we truly have what? A bunch of stuff in the list. Okay. So we need some sort of a loop to step through the list. So let's set up that structure first before we get into the algorithm of detecting if we find a node that meets our requirements, which means the rec key equal the client ID. Or in our case, the key, since the client ID was automatically set to key. Okay, so first, the while loop to traverse. So while position is not equal to null. Let me put a curly brace here, close curly brace. So this is going to be critical to the control of this batch of code as to what's going to happen. So very important. So let me just put at the bottom, at the bottom of this while loop here, within the body of the while loop. How do I move forward? Okay. Well, we know to move forward, all you have to do is do this. Position equal position next. We've used this over and over in other functions, right? Where we had to traverse, like push front, the print, right? So if you go to the print, like the view list, we use that technique right here, where as long as position is not null, go ahead and move or make position equal position next. So it means point to the next item, right? Otherwise, you will not move. You will be stuck on the first item. This loop will loop to infinity. So we're using the same technique here, except I'm going to add one more thing right before it, is I'm going to create what we call the offset. Okay, so previous position will be equal to position. So it's always lagging behind it. So the next time we come back through the loop, we have one position behind this one. Okay, so what happens if you do, if the key actually matches? Okay, so we're going to have an if statement where the position key is going to be equal to what you pass to the function, rec key. Okay, so what happens during that if statement? Well, it all depends. Did you find it in the head of the list, or did you find it somewhere beyond that? So if it is in the head, then we need a nested if statement. So if position equals head, then we're going to make head equal position next. Okay, else previous position next equals position next. Okay, so those are the two scenarios. Once you're done, remember, this is how you were able to reassign. So if you were, so what are you going to do with position? Release it and get out of this while loop. So we could free position, set the flag to true before you leave, okay? Because you want to make sure that the return will be true, right? You could have said return true right here and break. So again, you can re-massage this code any way you want. And okay, well, let's see if this will work. So let me go ahead and rebuild all. And let's see here what I have. Misspelled client. So let me just go back here. Rebuild this. Okay. Let's see. Client list, previous position. And what is it saying? Client list. I had a lowercase l here, so uppercase. Okay. Always read at the bottom your first error, and it shows me that I have a lowercase l here. So don't get overwhelmed if you get tons of errors. It's not a big deal. Just always concentrate on the first one. There you go. All right, so let's see what's next. Oh, well, this one is a classic. I forgot to put a semicolon. Okay, so let's see what happens now. Rebuild all. And let's see what else we have. Position next, previous position. I bet you I misspelled something. So let's see. Expected unqualified equal. Aha, yes, indeed. What's that equal? Let's see. I missed right before the equal. I forgot to say next. Right. So that's what happens when you think faster than you type. So let's go ahead and rebuild all and see what happens now. Okay. So again, we're running into another situation here where we have position and I misspelled position. Okay. All right. Recompile, rebuild all, and we're good to go. Okay. So now let's go ahead and test it. Okay. Where can we test it? We can test it here. Right. So we can test it in our application. We can go ahead and delete one of the items. Let's go ahead and delete Jane Fonda and see if we can get Henry Ford and Frank Sauce to appear. Okay. So how would we go about that? So you could do something like this. CL list. Use the operation delete record. But we're going to do it in maybe a Boolean. And since we want to return a Boolean, if it happened or didn't happen. So if, and we're going to go ahead and do CL list. We want to delete record. And which one? The one that has, so first supply the list. So CL list. Next, and that would be T99X45. That is what I want to delete, the record that has that ID. And if it's true, we'll go ahead and do a cout, record removed. So that way we'll know there was a record removed. Let's see here with my code, and let's put an endl here. And let's see here, finish up the quotes. Okay, well, let's see if it works. So initially we would have had 3 records. So by the time you're doing the view list, you should be seeing 2 minus Jane Fonda. Okay, or basically 2 records and no Jane Fonda. So let's see if this will work. Compile and run. And let's see, delete CLEs. I'm missing 1 parenthesis. It's an if statement after all, right? So this is the evaluation. Okay. Compile and run. And there you go. And let's see if it did. So indeed it shows 2 records, and it shows record removed. So we have Frank Sauce, we have Henry Ford, and sure enough, Jane Fonda is not in the list. So let's delete somebody else. Let me just retype somebody else. Let's delete Frank Sauce, NY 100. So it's really a good idea to check if you can delete an item at the end of the list, at the beginning of the list, somewhere in the middle. So let's compile and run again. And sure enough, Frank Sauce disappeared, and we still have 2 records, Henry Ford and Jane Fonda. Well, let's go ahead and get rid of Henry Ford for now. So let's go ahead and do this. MOD, T10, okay, and compile and run. Sure enough, now we have Frank Sauce and Jane Fonda remained in the database, and where Henry Ford has now been removed from the list. Okay, so I hope this was easy enough to understand and be able to replicate. So the new function that we created is the delete record. Let's go over it again. So you have 2 pointers, position and a previous position. At the beginning, they're all both pointing at the same thing, okay? Remember that I am going to use the delete record in a way that where it returns a Boolean. And in my case, I used it within the body of an if statement. So that means it will return my true or false right here to let me know that a record was removed. So that's the capability that I wanted, and this is why I put a bool in front of it. So let's go back to, again, the design here. So one of the first things we want to check if right here the list is empty. If it is empty, go ahead and return the flag that you already had set to false. Okay? And that'll kick you out of this function. You will not get a true, so the record remove right here will not appear on your output device, and nothing will happen to the list. It will remain the same. You haven't done anything to it, to remove anything. However, now, else means the list is not empty. Well, the list could have 1 item. It could have several items. This is we had an evaluation. But before you do that, I needed a loop that allowed me to traverse the whole list, if possible. Which means the moment I have an encounter with what I need to break. And make sure the flag is true. So when you break, you're basically at this line here, you're going to return a flag. Great. This here means if I do find a match, well, it depends where the match was. Was it at the beginning? If not, it's anywhere else. Because that is a particular case. If the position is head, which means your match here was done the moment position was still equal to head, which means it's your first item. Right? Then go ahead and make head equal position next. what you've done in essence is you've shifted head to the next item. Does that make sense? Okay, good. So, what else? If else means what? The position key equal record didn't happen at the first item. It happened at the tail. It happened anywhere else. Well, that's great. Make your previous next equal position next. Okay? That's how you're going to create that link and bypass the item you want to delete. Now you can go ahead and remove it out of memory. Okay? That is the item you're deleting. You're done. Go ahead and set the flag to true. Get out of there. Or I could have done all of this by return flag right now or return true right here as a statement. Again, I'll leave it up to you how you want to modify any of this. For me, it's just making sure you understood the logic of ablation or removal of a record. Okay, so on that, we are done with our series here. Stay tuned for another set of data structures where we're going to be doing, we're going to inherit from the list two classes. One will be for stacks and the other one will be queues. So we're going to reuse some of these functions that are already within the client list. We're going to use this client list class and its implementation for our next project. Okay, so it's important that you replicate this code as much as you can, so that way when we go to our next topic, we're going to be reusing this code. Okay, so on that, thank you so much. See you again for the next series.